Hello and welcome back. Today I'm gonna be solving hacknote. I'm skipping double sort because I tried it once a couple of days back. I was not able to stream as the internet was not that good. So I already solved double sort. Today I'll be doing hacknote. Let's see. They have provided a libc. So let's check that. 32-bit. Okay, do we have libc here? This build ID. Mm, Not much. We only have this, so we might not have debug symbols for this. Anyways, let's do a check sec. Oops. Check sec stripped binary dynamically linked NoPy NX canary partial railroad. Looks okay. Let's directly open it in IDA. Okay, IDA. Yeah, so set buff to std and std out, not buffered. Maybe this is menu reads and converts to integer. This can be our choice. You have this. Okay, let's see. Menu says add, delete, print. So try is not equal to 2. This is 2. So this is free. Probably delete. We can name it delete. Then we have 3. 3 is dump. You have 1. This is add. Looks okay. We go to add. Counter is checked if else full. So this could this is incremented on every add, or yeah, incremented on every add. Return this. Okay, so this could be a counter. You can call it a malloc counter. So here we have this is greater than 5. It will not go further. We have a PTR. It's white star. So this is global array to store whatever hacknote nodes we are creating. So node size, and based on your size, it will alloc another. For this, we are setting it to this function. Okay, this is like the main dump function, which is added to every node as a function pointer. So this structure should be simple. Let's add one. I'm gonna call it entry. This should be in size. I think it's the word should be unsigned. No, this is not size. It's actually word star func, and then we have a char star node itself. Then if we go to add, we can cast ptri instead of void star. We can call it entry star. So func is mained up and node is malloc. So when you uh, call this function add, there will be a malloc of size 8 and there will be a malloc of size something that you control. All right, and the entry will be populated to a global, we can call it table, maybe alloc table. Yeah, so then it is read into node. Whatever your size was, no overflow there, and then counter is incremented followed by canary check and return. All right, so add is done. Then we have dump. So in case of dump, it asks for an index if the index is greater than a counter out of bound. Otherwise, okay, so the function is like this. Function is called with the alloc table itself as the index itself as parameter. So hmm, I think we can rename that function type, but that's all right. Let's okay, dump is okay. Let's go to delete. So in case of delete, same as for an index greater than this, then should fail. If that is there, then we free note first, followed by the entry itself, and that's it. And that's it. That's all the code we have in the binary. Main dump. Okay. So some issues that I see here is in delete, although it checks if alloc table was earlier non-zero, but after freeing it doesn't set it to 0. So alloc table is not reinitialized after freeing, or you can say set to 0. So this can lead to a double freeze, I think. And we have two freeze, so we can have some control. Then we have dump. So this also doesn't check whether the memory is freed or not. So if we free it, this can be used after free. So we have two bugs. This menu is nothing, main is nothing, add. So add is like first fit, whichever is not been assigned to whichever entry in the table has not been assigned, it will create a new entry for that, and max you can go is 5. So if you check, by default the value is 0 and you can't go above 5, so I think that limits the number of allocations that we can do, because once all the slots are filled we won't be able to alloc because of this check. Yeah, so uh first thing first, I think let's look at the libc version first, because libc is 2.23. If I run it on my machine, mine is 2.27, so we'll need to do ld preload. So we got a segmentation fault because maybe our ld is not compatible with the this version of libc. So uh, according to some discussion on the website, I think it's Ubuntu 16.04. If I start a Docker container, which I already have here, this might be able to load our binary. That's all right. We don't need that. No. Okay. So this is 16. 16 doesn't work. So the best option that we can try is we can go with the LD. So how we can do that is based on an earlier challenge. So let's say I solved 3x17 calc ORW and start. So we can get a shelf not on this challenge but on three of these challenge, and then we can maybe copy out LD from that environment. So the easiest thing we can do is that. So I have already done that. So what I'm gonna do is I'm gonna copy. Uh, Now if we check LD is okay. So now we can probably run. Yeah, so it's so in this case we have a custom load, not the default loader that our Linux will use. If I run this binary as dot slash, instead I copied the loader from the remote system using the shell we have in other challenge, and I'll be using that to run the binary with the libc that we have been provided. Let's see, like look at the chal once. So exploitation will be different because the libc versions don't match. My system is 2.27 and the provided one is 2.23, and there have been a lot of changes, like one of them that I remember is tcache, adding tcache from that version. So if I do add and I say, let's say 10 lol, if I delete it and say next 0, I might be able to delete it again. Yeah, so what this does is so in this case when we malloc the entry for this table of size 8, this is a fast spin chunk. In fast bin, most of these sizes, which are small, fast bins is the fastest of all the bins to serve. All others they use doubly linked list to cater the needs of malloc. Fast bin uses a singly linked list and it has lesser checks in this case. So if we read how to heap here, we have an attack called fast bin dup, triggering malloc into returning an already allocated heap pointer by abusing the fast bin free list. Now, how that happens is if you free a chunk, it usually goes to a free list. So fastbin maintains its own free list of different sizes. So let's look at this example. This file demonstrates a simple double free attack with fastbins. So three chunks are allocated. We have their addresses. Then you free the first one. If you free again, things will crash because so there's a check that just checks if the top of the free list and the current freeing thing matches or not. So here it did not crash, I think, because it is running with tcache. Let's try running it here. 10 lol, and we have 2 0 2 0. Oh, it's still we are able to free. Success. Okay. So in this case, maybe this libc event does not have that check. So what the trick is, you free a, then you free b, and then you free a again. So in this case, they say, yeah, so you free a first, then you free b, and then you free again. Now you have three, like these pointers will be same. So if you malloc 2 3 times, then you'll get this pointer first, followed by this pointer and this pointer again. So two objects will have the same backing memory. This might lead to some side effects that you can later use to exploit. So in this case, this should be easier because our alloc table malloc 8u, the first 4 bytes contain address to a function, which is like very similar to a jump table, but not exactly it. It directly contains the address of the function. So if we just replace this value, we'll be able to call functions arbitrarily. So yeah, so my current uh, plan to attack is that we allocate two different chunks or create two entries in the table. Both of these entries will automatically malloc of size 8, and we can keep the sizes different, like this size different, which is asked for the node, not the entry itself. So let's say 100. I call add twice with the 100 size. Then once I have that, we'll be using this similar attack to free office work is open right now. So oops. Yeah, so we create two large chunks. They automatically malloc of size 8. Then once we have that, we free these entries. So those 100 are freed. What that gives us is then if we malloc again using this technique that we saw in this, once we malloc again, we get uh, so this time I malloc of size 8. Now, when I malloc of size 8, both of these 8 chunks that we've malloc from here will be in the free list. One of them will be used as the entry. The other one will be used as the note itself. So we'll be able to arbitrarily control the data for that note. So what I'm let me explain by an example. So let's say node size 100. We'll say lol add node size 100 the bowl. So now we have two nodes. What I'm gonna do next is I'm gonna delete one node. This frees the both of the entries of size 8 and 100. So now we have two chunks in different free lists. Now once we have that, I'm gonna free one again. So right now, both of the entries, so in this case, this entry of index 0 and 1 are in the free list. Now if I allocate, or let's say add one of size 8, and I say 8, 2, 3, 4 BBB. Yeah, so now if I try to print the first one, oops, totally failed. Let's do that again. One, says 100, content is lol, then one node says 100, press go, then two you delete 0, then two you delete 1, then when you add node 8 2 3 4 1 2 3 4. Now once you have that, we can say okay, you give me print, and we have this, and we can see that there was a crash at 4141 4141. So this happened because in this case we allocated a size 100, which was additionally it also allocated 8 for the entry and 100 for the node. Similarly, we have two. Now we delete both of them, so we have both of these in the free list, but their references still lie at index 0 and 1. So although they are both free, now what next I allocate of size 8, both of these chunks that we freed, or entries that we freed, are now under our control, one of which I used to write a and bb. So the address is still there, so now I get use after free on an initial node which called this as a function. So we got a crash on 4 on 4. So this is I think quite easy a bug. So after getting arbitrary, let's say I have I can make the jump to any IP because of our control. But since let's see drop gadget, since the binary is not statically linked, we won't have syscall gadget in this. And also system or any other function has not been used in this binary, so it's not there on the got or plt. So our next thing is that we leak. So the next attack, or the however I use this primitive, is I'll try to leak system from the libc, and using this primitive I'll try calling system bin sh. So how do we leak is okay, so right now we have control over this and this, and we already have a function that gives us something. So if in normal scenario this function is used to call over this node, the entry for this node, and this dereferences the second pointer and dumps it using puts. So if we have a control like this, uh, control over the call, like the eip and the address that uh, this function, this puts, will use to dump some memory or to std out, we can use this to leak let's say got. So once we leak got for some function, we already have the libc provided by, sorry, so we already have the libc provided by pwnable.tw. We have all its symbols, so we can defer the symbol whatever we leak from this. In this case we can leak the puts got itself, because puts has been used uh, in this case puts has been used multiple times in menu, so puts got entry will be filled. not unlike other we can't be sure of. A to I will be filled, so we can leak A to I or puts, even malloc. We can leak free, maybe printf2. All right, so once we leak that GOT entry, we'll have absolute address of puts, so it will be in the context of libc. Then we find out the address of system in the libc, we subtract, and then we have absolute address. And then we do perform the same attack to call system bin sh. I think that should work. Let's start writing something. So how the program looks like is it's called hacknote. So born import star. So we need to put in the context of process here like such. So I think we look at the documentation. Yeah, so we can pass this as an array, and we can say use my ld. Then we can say use hacknote followed by env equals, this should be a dictionary. uh, I think this should do it. Process so hacknote, and that's there. Now let's write functions to allocate and free. Now alloc is send one, in this case one. It asks for a size, you can say 10, asks for content. So we need two things, one is size, then we have content. First thing first is dot receive. Now once you have that, you send one. That is that. Then you send size. So that works. And then the content itself, so start use send in this case, because it's using read, and with extra characters we can, if we do, like in this case we used 8, I gave in a control D here so that it doesn't take the slash n and use it as the next input. So you have that, then it says success. So you can say this will alloc for us. Then we can say def delete All it needs is an index. So same, actually no, we can do this. So this will be 2 in this case. Address is, oops, then it asks for an index. So then yeah, then we have dump itself. So in this case dump also needs an index. This should be 3 and use an index, then it sends yeah, it will send your payload with a line. All right, so instead of that we might be able to use so 3, yeah, so this could be returned. The plan is that we allocate 200 dummy bytes. uh, what this will do is it will fill 0 and 1 indexes. Now we delete 0 and we delete 1, and now we alloc of size 8, which in this case should be our function puts, no, not puts, main dump itself. So we have uh, main dump plus followed by what do we want to leak. So that could be we can do context dot, I think context dot binaries. Yeah, so context dot binary. We have elif dot got outputs we can say print dump 0. I think instead of print we can call it let's see how this goes. Oh, oops. Hmm. Oops. So I have unbinded my Vim. For Vim, I have unbinded my arrow keys so that I don't get that habit of using the arrow keys. Let's see. Yeah, okay. So this looks promising because let's have a look first. So different libc doesn't matter in case I just want to look at GOT. So that's that. Yeah, so this is the order in which the GOT entries are there. So let's call it leak is equal to dump 0. Why now I'm using 0 because 0 was the first to be freed, it will be last in the free list. We can say success x of u32 of leak 4. I think there's a better oops. Yeah, so in this case I was able to leak something. Let's see. So puts will stop when there's the string actually ends. So in this case we can say let's do 4 to 8. Yeah, so let's look at this entry. In case of puts, it is followed by exit, but we haven't exited yet. So we have 804.884. Yeah, so this verifies that we are actually leaking puts in this case. And we can also do we can print puts in this case. Let's match the LSB. So 140 and 140. Yeah. So in this case, that is actually puts. So now we have leak of libc's put. So let's also load the libc in context of this script. I is equal to emf. So we have libc, we have puts address. I'm gonna do that as puts is equal to, we use this. We have system is equal to puts minus, we have the symbols to subtract the offset of puts and add. Yeah, so now we have puts and now we have system. So we'll use the same technique to call binsh. So let's do that. Should I just copy? Oh no, oh no, no, no. We can't use this technique because we already have one, two, three allocs. 4, 5, 6. We won't be able to use. Okay. So we have systems address. Mm, can we call delete on 2? We can't call delete on 2 because the entry is the last thing to be freed. So if we look at free, in both of these frees, the table entry is the last thing to be freed. So we won't be able to use the same attack for this one. So what we can do instead is let's see. Yeah, 0 to 4, so that means 5. We already have used 3. Now if I do an alloc, we have used 0, 1 and 2 is there. Can we do it with 2 allocs? Why do I have to use that? Let's create one. Uh, we'll delete that one and this one. So and then create the same. So let's just do one dummy alloc, say 100, and we can call it dummy. Then we can delete 2 and we can delete 3. This should not be a problem. Oops. So now if I do this, this time I want to use system, and what do I use as parameter? Okay, let's see if I first hit system. We need to attach GDB. Let's set up a breakpoint in this case. Maybe say dump. here. Yeah, I want to set a breakpoint here. I think this should be what I need. Let's verify for a dump here, and the index of uh, this will be 4. We don't want to use 4. We will dumping 2. Okay, we have that is alright. I think this is leak, so we'll be using same function to call this time. Rex is somewhere else. I think I messed something. Let's just check. So we have this. Once we allocate this, we'll have 200s in the free list, and no none in the 8 size free list. For fast bin, we allocate 100, so we get one chunk, and then we put in dummy. We delete 2, that means we delete this one. Then we delete 3, that means we delete this one. Now we have in the free list, the last thing freed will be entry for this, followed by an entry for this. When we alloc, this should overlap with this. Hmm. We have all getting success. Let's do dump in that case. First hit, second hit. Let's look at the heap. Suppose this is the heap. This is the heap. Can verify it from the entries. Yeah, so okay, 0 has the address system, but why does 0 have that? So once I read this, so 1, 2, and 3. 3 has ok's address because 3 is this one. 2, delete 2. Actually, this, let's look at this. Let's change this for now and see if it works. Yeah, okay. Yeah, so we'll be able to call ex, but the parameter that is getting passed contains system itself. Oh my god. Oh yes. So for this we have a main dump. So instead of calling main dump, we are gonna call system, and that will be an address of the entry, I think. It's dump. Yes. So that will be a pointer to the entry. Now, how can that help us is if we do x-access, we have very random garbage, most of which is packed this address, followed by an address of duty of puts. Okay, so one thing we can try is we can try sending this. It doesn't need to be p32, I think. Let's see. Hmm. This is better, but I think there will be an error that this is not there, but we should get sh. So this is a trick I learned from CTFs. Clean star. Skill because of SIGUP. Okay. 1, 2. We continue. We oh yes. I think this was even easier than doing start. Let's let's see if this works on remote. Although I don't have this on good authority. It's very slow. Oh, it is waiting for receive line to end. Yes, it is waiting for this receive line to end. So what I'm gonna do instead is I'm gonna say timeout equals 2. Think this should work. We'll wait 2 seconds and then give me shell, I suppose. Ah, yes. So we have use after flee in hacknote. So although I started on a different note that I'll be using dup2, that was my first assumption that I'll be able to do that. But since here we have a way of calling arbitrary, so at let's say this offset we were able to get or call something else to fulfill our leak or get other primitive, I did not use this way. Although it could have worked similarly for this case, we could have freed this chunk followed by the string again, and then when I alloc, I will be able to get control in a similar way. But I think this is better. Uh, we also did not verify the check that we get with the this binary. What sort of check is there? So that's it. We have so even after freeing, we can use using dump function. We can use already freed functions. This gives us a simple use after free primitive. How we exploit that is since we already have a function pointer control, we use the dump function provided internally to leak one of the GOT entries, in this case puts. And using that GOT entry, we calculate the address of system from the libc provided. Once we have the libc system, we use the same primitive to call system sh, I think, in this case. Uh, yeah, so that's it. This was a pretty simple challenge here, and also this concludes our stream for today. See you next time.